In this lecture, we're going to talk about the atomic structure. Basically, the structure means location, position, placement of particles in any space. Like, we can say that if a atom consists of a proton, neutron and electron surrounding it, we can say that it's an structure. We are just talking about the locations, the placement in space and the position of the particles. So, in an atom, there are three basic particles: electron, proton and neutron. In this lecture, we're going to talk about the electron, but somehow electron is relatable to the proton. The experiment used in both particles discovery is same, and that experiment is called electrolysis. Electron was discovered by William Crookes, but the proton was discovered by Goldstein. So, we're going to just talk about the electrolysis with respect to electron. So, in the electrolysis, it is the passage of currents through low pressure in discharge tube. Passage of currents means these charges, positive, negative, are passing from a low pressure. Pressure means with low particles. Like if there is low amount of particles, we can say that there is low pressure on the surface or on the medium. So passage of current means passage of charges through low pressure in a discharge tube. So what is discharge tube? We're going to talk about it in detail. So first we're going to talk about who discovered the name electron. Stoney discovered the name electron, and the process by which the passage of current become possible is conduction. So, what is discharge tube? The structure of discharge tube is somehow like this. Here, the structure of the discharge tube is made up of glass. This is a vacuum pump. It's just for providing the medium to the particles. This is a negative terminal which is connected to the negative part of the battery or negative terminal of the battery, and here is the positive terminal which is connected to the positive terminal of the battery. So this terminal is known as anode, and this terminal is known as cathode. So, this is a battery. Let me just write it. It's a battery. So, this is a basic structure of a discharge tube. Now, let's talk about the passage of the current. Let's suppose if here is like high density or high pressure, what will happen? We're going to talk about that in the Act 1. So, in the Act 1, in normal temperature, let's see if there is normal pressure here, what will happen? These current or these charges will pass, and there will collide with a particle or a pressure particle. So what will happen? That charge will be diffused. Somehow, these charges will be unable to just come out from the terminal. So, this will fail. No conduction will happen because of the normal pressure or normal temperature. Let's talk about somehow when the pressure is lesser, we just take out the pressure or take out the medium or just make the medium lesser than the normal one from the vacuum tube. So what will happen? These particles or these charges will just head to the positive terminal, and they will also collide from the pressure particles. Somehow some will just reach the terminal, some will just collide from the particles. The particles which are just collided to the pressure particles will glow up. By this scene or by this collision, a glow in the tube will happen. There would be less conduction, but the glow will be happen. And this is happen in our daily routine during usage of the bulbs or the tubes. This happens in the tube. So let's talk about the Act 3. What happens if the pressure becomes 0.01 torr or 10 raised to power minus atom, which is the least or the lesser pressure? So what will happen? Less gas particles, more conduction, and there would be a dark side of the tube. Like if no particles or no charge are being collide, so where should be the glow will collide? Glow will become. So there would be a little bit glow here. And these glow is known as cathode rays. We can say that these rays are known as cathode rays, and this is the discovery of the negatively charged particles, because only the negatively charged particles will be attracted to the positively charged particles. So we can say that these glow will be named as cathode rays. Now for that experiment, we need up to 5,000 to 10,000 volts. Like 5 to 10,000 from here and 5 to 10,000 from there, and this will happen or this will be done with the pressure up to 0.01 torr or 10 raised to power minus 4 atom, and with the current flow or the current amount of 5,000 to 10,000 volts. This is how this process electrolysis will happen. Now the apparatus name is somehow distributed with the names of the founders. Now let's talk about the founder, William Crookes. He just named this apparatus with his name, Crookes tube. Another name is Gasler tube. He was the first person to make discharge tube, so he just named the discharge tube with his name, Gasler tube. And third name that we are familiar to is discharge tube. And that's all about today's lecture.